Separation techniques. Separating solid from liquid. Filtration, evaporation to dryness, crystallization. Filtration, a method for insoluble solid. Residue is solid left on filter paper. Filtrate is the liquid passing through the filter paper that is collected. Filter paper has pores that allow solvent to pass through but not large enough for the larger solid particles to pass through. The use of this method is for purification of drinking water. Evaporation to dryness, a method for soluble solid. Heat the solution until all the water has evaporated. This is achieved by direct heating, which is what you see on the left. Or heat over steam bath, which is what you see on the right. The dissolved solid must be heat stable, and won't decompose, upon strong heating. Solid loses water and becomes anhydrous. This method is for harvesting salt from seawater. Crystallization. Heat a solution, to remove most of the water, until a hot saturated solution is formed. Cool the saturated solution to room temperature to form pure crystals. This method is for solid, that is not heat stable, and decomposes upon strong heating. This method is for production of table sugar from sugarcane. We will now take a closer look at the procedure of crystallization. Heat the solution until saturated solution is formed. Then cool the solution to allow crystals to form. Lastly, filter to collect crystals and wash it with little cold distilled water, and then dry between sheets of filter paper. Separating solids. Using suitable solvent, magnetic separation, sublimation. Using suitable solvent. Let us separate sand and sodium chloride. Use a suitable solvent, liquid that dissolves the solute, substance that dissolves in solvent. Dissolve sodium chloride and sand mixture in water. Sodium chloride dissolves but not sand. Let's carry out filtration. Residue, sand, wash the sand using distilled water and dry between sheets of filter paper. Filtrate sodium chloride, then obtain sodium chloride crystals via evaporation to dryness. Lastly, wash crystals with little cold distilled water and dry between sheets of filter paper. Magnetic separation. Using a magnet to separate magnetic substances from a non-magnetic substance. Example of magnetic substances are nickel, iron, cobalt, and steel. Examples of non-magnetic substances are sulfur and non-metals. Electromagnet is used to separate iron and steel from other junk materials in scrap yards. Sublimation. It is used to separate a solid that sublimes on heating from one that doesn't. Examples of solids that sublimes are iodine, ammonium chloride, and dry ice. This method is used when dye is transferred onto paper or fabric using heat during printing process. Separating liquids. Simple distillation, fractional distillation, separating funnel. Simple distillation. It is a process used to separate pure liquid from a solid liquid mixture. Liquid is heated to gaseous state and cooled to condense as a pure liquid, leaving the solid or other liquid in the mixture. This method is used to obtain desalinated water from seawater. Let's take a look at this simple distillation setup. In the flask, the solution boils. Water vaporizes, rises and enters the condenser. In the condenser, vapor is cooled and changes back into pure water. Pure water is collected as a distillate in a conical flask. The salt solution in the flask becomes more concentrated as distillation continues. Features of simple distillation setup. Use porcelain chips or boiling stones to ensure smooth boiling. Water runs from bottom upwards to fill the condenser, and ensure vapor is cooled as it enters the condenser. Thermometer, a tool to record boiling point of liquid entering condenser to check purity of distillate. What is fractional distillation? It is a process used to separate mixture of miscible liquids with similar boiling points. Glass beads in fractionating column have large surface area that can cool hot vapors that rise up the column. Liquid with higher boiling point will condense along fractionating column and fall back into flask. Liquid with lower boiling point will distill over first. The use of fractional distillation is to obtain pure oxygen and nitrogen from liquid air or separate crude oil into useful fractions. Now let us take a look at the setup for fractional distillation. Vapor rises up the column as the solution is heated. Vapor of the liquid with higher boiling point condenses in the column and falls back into the flask. Vapor of the liquid with lower boiling point reaches the upper part of the column and is distilled over. Thermometer shows a constant temperature. In the condenser, vapor is cooled and changes back into liquid which flows into a receiver. The pure liquid is collected as the distillate in the receiver. Separating funnel. It is used to run off a denser liquid from a mixture of liquids that are immiscible. And here is the procedure. Allow liquid to settle. Liquid B is denser so it will become the bottom layer. Open tap of the funnel and drain liquid B into beaker. Place another beaker below the funnel, and open the tap, to allow a little of the top layer of liquid A, into the beaker. The funnel now contains only liquid A. Separating components that dissolve in the same solvent. Chromatography. What is chromatography? It is a method used to separate two or more components that dissolve in the same solvent. Components move at different speed along the filter paper, resulting in separation into various components. More soluble solute travels faster and higher up on the filter paper. It can be used to separate dye and ink, and pigments in plants. Or it can also be used to identify banned substances in food, and to determine whether a sample is pure. Let's take a look at the setup for chromatography. Starting line drawn in pencil, as graphite in pencil is insoluble in most solvent. Small spot of dye on starting line, to prevent sample from dissolving into the solvent. High solvent front, to ensure components are fully separated. Lid, to prevent volatile organic solvent from evaporating quickly. Reverse osmosis. What is reverse osmosis? Normal osmosis is when water molecules move from an area of low concentration of solute to an area of high concentration through a semi-permeable membrane. Reverse osmosis is when water molecules move from a solution of high concentration to a solution of low concentration through a semi-permeable membrane. The process is repeated until pure water is obtained. It uses less energy compared to the process of purifying water. Now let us recap what we have learned today. Thank you for the effort to learn with me. Good job. That is all for today. Stay tuned for more interesting lessons from me. See you next time. Bye bye.